Good afternoon, everyone. Can you hear me all right?
Yes.
All right, outstanding. The plan today is to cover sections 1.8, 1.9, and also take any questions you might have over homework 1.6 and 1.7. So I'll take that first. Does anybody have questions or issues with problems on 1.6 and 1.7 for the homework? Anything we need to review?
Could you try doing 107 on 1.6?
107, 1.6. Okay, are there any other problems we should look at? Let's see if we can find 1.6, 107. Let's see what they're asking for. Okay, so it says, is that the one that says given y equals f of x equals cube root of x? Is that the right one?
Oh, wait, it's 105. My bad.
105.
Yeah, sorry.
1.6, 105. Let's see what that one says. Standard cubic. And then do the following. So that looks like y equals h of x equals 1/2 x minus 3 cubed minus 2. Is that the one?
Oh, yeah, that's the one.
Okay. If we're talking about starting, make sure here, 105. Yeah, starting with x cubed. So we're going to start with the basic function y equals x cubed. So if we were to graph y equals x cubed, we could create a table of values and say here's x and here's x cubed, and we could put in values, couldn't we? -2, -1, 0, 1, 2, and so forth. And we could come up with some values, couldn't we? And we would probably see that it sort of looks like that, doesn't it? Are we right? Do we have agreement there?
Yeah.
Okay. We could put in some points here, but we'd have a graph that looks roughly like that. And then what they're asking is if we take this basic graph and do this with it, make these 3 changes. 3 changes are 1/2 here. That does that stretch or shrink this graph, this 1/2 value?
It's shrink, right?
Yes, that's correct. Stretch, shrink. Meaning that it's not going to go as high in the vertical direction. So it's going to go only half as high. And how about this value out here? What is that value doing? This -2 here. What is that doing to a basic graph of something like this?
Down 2 for the y.
Right, it subtracts 2 from every y that we end up generating. So this whole curve, if we didn't change the shape of it with this, we would shift the whole curve down, wouldn't we? So this thing would come like this. We'd come through this point. So we'd shift, this would shift it down to. So this is y equals x cubed minus 2. This says it's not going to go up as high, so it's going to be a flatter curve. And how about this value here? What's that going to do?
Shift all the x values to the right by 3.
By 3, right? So we're going to take this and go 1, 2, 3. So we're going to end up with something over here, aren't we? Like that. So this original curve is going to go down and over. Okay. So that's really what they're asking for, isn't it? They're just saying what happens to this curve, this original curve here. And we could set up a table of values for each of these conditions, and I could put 1/2 x minus 3 minus 2, and I could set up values down here and plot those as well, couldn't I? But what's going to happen is it's going to shift this curve down. It's going to shift it to the right, and it's going to make it not as high. It's going to shrink it. So instead of being real steep, it's going to be less steep because it's not going to go up as high. That makes sense?
Wait, so you didn't require us to put in like points or anything? Or did you require us to put points?
Did I do what to the points?
Do you require us to like plot points and everything, or just draw the line?
Oh, if you're going to actually do it, you'll want to actually plot some points. Yes. I won't take the time right now to go through and plot every one of these points, but you'd want to plot the points. Yes.
Okay, then. All right, that sounds good. Thank you.
Yeah, sure.
I have a question about the beginning of that problem, the 1/2.
Yes, this part here.
Yeah, you said it was shrinking. What would it look like if it was not shrinking and expanding? How would that look differently?
All right. If we had nothing out in front here, if we just had this value here, there's nothing out in front. So that nothing is a 1, isn't it? That's like multiplying by 1. If we want to shrink it, we make this value less than 1, but greater than 0, which is what the 1/2 is. And if we want to stretch it, we make it greater than 1. So if we made this a 2, for instance, instead of 1/2, if we made it a 2, then we would double the amount that we come up with. If we come up with a 5, we would double that, come up with a 10. If we come up with an 8, we double that, come up with a 16. So we'd find that it's going steeper. So if we multiply by something greater than 1, we make it steeper. Something less than 1, we make it shallower. Other questions?
If there's a time, could you go over 99 for 1.6?
1699.
Yeah.
Okay. Before I do that, are we okay on the stretching and shrinking? So this value out in front would either be a stretch or a shrink. If it's 1, it wouldn't be either. And then this value would be a shift left or right, and this value would be a shift vertical up or down. So here's a vertical shift, here's a horizontal shift, and here's a stretch or a shrink. Okay. 1699. Is that the negative x cubed? H of x equals negative x cubed. Is that one?
Yeah, I think so.
You think so? Well, I'm not going to go all the way through it if you find out that's not the one you want it to be. So you make sure what you want.
Okay. So, I don't have it pulled up. Give me a minute, please.
All right. So I guess I would say to the class, anytime you want to ask a question, make sure you know which problem you're talking about, so we're not wasting the class's time on a problem that, oh no, that wasn't the one I wanted. I wanted this other one, because everybody's waiting for you. Okay, so please be ready when you want to ask your questions. That way we'll save everybody's time. Now, if we were to take a look at this one here and say, well, that really, if we let f of x equals x cubed, and we wanted to plot that, well, we could create a table of values and say x and x cubed and plot from -2, -1, 0, 1, and 2, and so forth, couldn't we? We could do that. And an x cubed, as we talked about above, is going to look sort of like that. We can plot the actual values: 0, 1, -1, 8, -8, go over 1, 2, -1, -2. And down here would be a -8. And up here we'd be a +8. So this point would be 2 and 8. And this point down here would be -2, -8. Everybody agree that's what that would look like? Any questions on how we did that? And then if we put a negative out here, well, we're going to change the values of this, aren't we? So that if we say negative x cubed, then what are we going to do to these values? We're going to reverse them, aren't we? So we're going to end up here. Maybe I'll do it a different color. So we're going to be here, come down through here, and come down to here. So if we do this, we're going to look like sort of like that, aren't we? Because we flipped all the values. Where these are negative, they're not going to be positive. So that'd be -2 and +8. And this would be +2 and -8 over here. So we've just flipped these values. And anytime you want to do this, just create a table of values. You know how to do that. Put in your x values, put in your original values, x cubed, and then put in your negative x cubed. You don't have to put in the positive x cubed. You don't have to look at this value. You can just look at the negatives and just multiply whatever you get by a negative value, which just reverses it. It reflects it across the x-axis, doesn't it? So this value goes to here. Okay, does that answer your question? Okay.
Yeah, thank you. Sorry.
Okay, no problem. Other questions?
I had a question about number 113 from homework 1.6.
113. That looked like, what did that say? R of x
Yeah.
equals 1/2. And then we took the cube root, x plus 2 and -2. Okay. So we could say the basic or the parent function might look like f of x equals what? Cube root x?
Yes.
That's the basic one we're talking about. So it's roughly going to look like we've shown, like that. And then what are we going to do to it? Well, we're going to shift it downward with this value here. So it's going to go down 1, down 2. So this same curve would come through here like this. And then this says we're going to shift it which direction? Right or left? So this is a vertical shift. This is a horizontal shift. We're going to shift left or we're going to shift right?
So my the one that I have is showing it turned sideways.
Well, we're going to shift it. We're going to shift this thing left. So we're going to go left 1, left 2. So it's going to come over here like this. And then the half says we're not going to be as steep. So we're going to be shallower by a half. So instead of going up 8, we might go up 4. So if we're shifted here, we might go up half. So we might look like that. Okay, let me take another look here. Let's see, 1, 6. Am I looking? Yeah, 1, 6. You're looking at the right one. 113. Yeah, so let's see. Yeah, we're going to shift that. We're going to shift it x cubed. Now let me see. Do we talking about the right one? 113. Yeah, it's the cube root. Oh, I'm sorry. I did x cubed. This is x cubed. So if it's the cube root, it looks this direction, doesn't it?
Yeah, that's what
Yeah.
I was saying.
Yeah.
Thank
So
you.
we're going to take this one and shift it. Okay, so we're going to go down 2 over 2. So it's going to come down here and then not be as, it won't go over as far. So instead of going over 8, we would go over like say 4. So it's going to increase, it's going to raise it a little bit. So it's going to go, instead of going over to 8, it'll go over to 4. So it'll be.
So I didn't have issues doing that part. The
Yeah.
part that I had problems with was the coordinates for the second line for the shift. I plotted the first set of coordinates, like I did the whole number thing, but the second one I just could not figure out. All of the y values were fractions, and maybe it's just basic algebra that I'm messing up.
Well, let's see here. If we go x and we go like what? -2, -1, 0, 1, 2. And we're starting off with y equals cube root of x. So we know that it begins this way. So then we shift it. So if we said cube root of x, so instead of saying 2, let's say something we can take a cube root of, let's say 8. So let's say 8 over here. So 0, 0. And if we go out here, 8, cube root of 8 is 2. So we're going to say this value is 8 and 2, aren't we? And then back here, we're going to go, if we go negative 8, 1, 2, 3, 4, 5, 6, 7, 8, here's negative 8. And we're going down to negative 2, aren't we? So here's negative 8, negative 2. So we have a curve that's coming like that for the cube root. And then we're just going to shift that thing by whatever it says to do. So if we say for 113, we're going to make it 1/2 times cube root, and it's x plus 2. So that shifts it to the left, doesn't it? And then negative 2 shifts it down. So we take this curve, shift it down. So it comes down to here. That's done by this. And then shift it left. That's done by this. So we take this point, move it over 2. So we're over to here. So let me get another pen here. So maybe we're over like that. And then we want just half the value. That's what this 1/2 out in the front is going to do. So when x is, let's say if x is 6, 6 plus 2 is 8. Cube root of 8 is 2. So let's say x is 6. Let's put a 6 right there. And negative 6. So if x is 6 plus 2 is 8, cube root of 8 is 2. And then we're going to take half times that. So half times 2 is 1. And then we subtract 2 from that, we'd get negative 1, wouldn't we? You follow that? We just plug in our value right here and then do the algebra. So,
so the book, the points that it had, that's why I was really confused. The x values were -3, -2, -1, and the y values were -5/2, -2, and then -3/2. That's what it was plotting at, and I don't really understand that.
okay, so if x is, let's put in x at 3. So if x is 3, 3 plus 2 is 5. So that's going to be the root of 5, right? Root of 3 and 2 is 5. That's what's the cube root of 5. So let me get out my calculator here. So
it would be better to just use whole numbers that I can get a perfect cube to just get rid of all that.
That's what I would do. You
Okay.
can certainly do it with your calculator. If you want to put in a 5 here, we'd say 5 plus 2 is 7. And then you want the cube root of 7. So you'd say, well, 7 to the, where is it right here? 7 to the 1 divided by 3 power. 7 to the 1/3 power is 1.91. Divide that by 2. That's this thing here. So we divide by 2. And that gives me 0.95. And then I subtract 2, which is this value here, minus 2. And I get -104. So all we have to do is just use this for any values of x we want. We can plug in 0, 1, 2, 3, 8. We can plug in any values we want. And we don't have to come up with just whole numbers. We can come up with any number the calculator gives us. And it says, well, if x is 3, then y is going to be -1.04 type thing. Again, just create a table of values for x and whatever value you want to put in here. Okay, does that make sense? And then you can just plot these values of -8 or -5 or negative any values you want. What I tend to do is see if I can get this thing to be some sort of a whole number. So if I say x is 6, if I go out here to 6, so 6 and 2 is 8, and I can take the cube root of 8. So if I go out here to 6, which is here, and then I take the cube root of 6 plus 2, that's 8. And cube root of that is 2. So that means I go up 2, 1, 2. So I'm sitting here. And then I take half of that. So I'm sitting at 1. So I'm sitting here. And then I subtract 2, 1, 2. So now I'm down here. So I'm at 6 and negative 1 for this
And then that would
point.
be what you would put for your plot for
Yeah, that'd
y.
be, yes,
Yeah.
yes,
Okay.
exactly.
Perfect. Okay,
And-
thank you.
And I could do that for any values of x that I want. Generally, on something that's a curve like this, you probably want more than 3 points, because if you had just 3 points, you might think, well, that looks like a straight line, just 3 points. So you might want to put a couple of points in a little closer so that you can see, well, actually it's coming kind of like this and coming like that. So anytime it's a cube or a cube root, you might want more than just 3 points. Certainly more than 2 points, because you can't tell anything on something that's bending that much. Okay.
Okay, thank you.
Yeah. Other questions? Anybody?
Could we do in 1.7 question 89?
1789. Let's see what that looks like. 1.789. Let's get that out of the way. 1789. That says graph f plus g of x, right? Which looks like f of x plus g of x, doesn't it? And it shows you the points. Well, it shows you the graphs. It shows you, let me put this book under here. It shows you this graph right here, doesn't it?
Yeah.
It says on this graph, do f plus g. So let's take point x is 0. So if x is 0, f of x or g of x, the red one, is what value?
Looks like 1.
Looks like 1. So that would be 1 plus f of x, the blue one, looks like 1, 2. So 2 plus 1 is 3. So f plus g would be at 3, be up here. And you just do that with each set of points over here.
Okay, thank you.
Yeah, and you can only do it as far as the blue line goes. You can't go out here because we don't have red to go with anything. So the farthest we can go is 1, 2, 3. So if we go over to 3, well, this says we're at negative 3 and 0. So that point, the next point would be here. Negative 1, positive 1, the point would be here. So we'd have something that's coming down through here and comes down to here. And similarly on the left-hand side. So if we add them together, we'd have 2 and 1 is 3. Let's see, 2 and 3 is 5. So we go up here to 5 and so forth. We just add the values together. And again, we only go over on the blue until it hits negative 4 and 0. Negative 4 and 0 and negative 4 and 5. So that point remains the same. And this point we don't include because there is no blue value for this point here. So we're simply combining the points, add, subtract, multiply, divide, whatever they're asking us to do. If it's f plus g, then we just add the y values at each x coordinate. That makes sense?
Yeah, that helps a lot. Thank you.
Okay. Other questions? Okay, the plan today, as I indicated, is to go over 1, 8, and 9 if we've answered all the questions on 1, 6, and 7. So let me get that out of the way. And 1, 8 talks about inverse functions. So we're going to define what those inverse functions are and then see if we can work with the inverse functions. So if we were to define 1.8, so if we're looking at inverse functions, there's several things we may want to do. We may want to verify whether the function has an inverse or not. And we'll look for tests to do that. we might want to find the inverse of a function. There's something called a horizontal line test. Where horizontal line is going to be this way, parallel to the x-axis. And there's a test we can use to determine if the function has an inverse. And we may want to graph a function and its inverse. We may want to graph a function, and I'm going to start using the notation that the book uses. If we have a function of x that looks like that, then the inverse of that function looks like this, f inverse of x. So if I say, here's a function, and I give you some definition of a function, whatever it happens to be, then if I ask for this, I'm asking for the inverse of that function. Okay. All right, so let's go ahead and take some examples and see if we can explain some of these concepts then through the use of examples. So if I give you a function f of x equals 4x minus 7, and I give you a g of x that looks like x plus 7 over 4. And if I ask you to find the inverse of this function, which is f inverse of x, what the process I go through to find that is step one, I substitute y for f of x. So I say y equals 4x minus 7. Step two says I interchange the variables, or I swap the variables. So whatever I have it, y here, so I'll call that an x for y minus 7. So I've just interchanged these variables. Thirdly, I'm going to solve for y, just like I usually do when I'm plotting y equals some function of x. So I'm going to solve this for y. So add 7 to each side. Then I'll divide through by 4. That cancels on the right. And I come up with an equation that says y equals x plus 4, or x plus 7 over 4. And then I'll substitute for y, I'll substitute that inverse. So I'll say inverse of x equals x plus 7 over 4. So I started out with this. This was given. Some function of x equals this value. And I'm asked to find the inverse. And here's the notation for the inverse. F negative 1 exponent. It's not really an exponent, because if it were, it would mean 1 over something, wouldn't it? But that's not what we're doing here. This is the inverse of this function. So process then step 1, substitute y for f of x. Step 2, swap or interchange the variables, x and y. Step 3, solve for y. And then step 4, replace y with the inverse notation, inverse function of x equals. So here's the function, here's the inverse of the function. Okay, questions on what we did to get the inverse? I'm going to do that same thing with this g function.
Could you explain how you did step 3 again?
Step 3, I just solve for y. You can forget this problem. If I just said x plus 7 equals 4y, and I said this is just an algebra problem, solve for y. Could you solve that for y?
When you just divide by 4 both sides?
That's correct.
Oh, that's what you did, right?
Yep.
Oh, okay, I get it now. My bad. Thank you.
Okay, no problem. Okay, so now what we want to do is the same thing with this function. So I'll say find the inverse function of g. And I'll say, well, step 1, step 2, step 3, step 4. Step 1 says I'll let y equal x plus 7 over 4. Step 2 says I swap or interchange the variables. So the y becomes an x and the x becomes a y. And then step 3, I solve this equation for y. I'm going to let you guys do that since there was a question last time. Take this x equals y plus 7 over 4. I'd like you to solve that and then turn on your mic and step me through your procedure to solve that.
Would it be 4x in the numerator, 7 in the denominator equals y?
4x in the numerator and then 7 in the denominator equals y. Is that what you asked? Is that what you said?
Yes.
Okay, I'll write that down. Everybody agree?
I got 4x minus 7 equals y.
You got 4x minus 7. So we have two different answers. We have y equals 4x over 7 and we have
It's the
y equals,
second. It's the second one. I'd messed it up.
okay, so everybody agree this is the answer? Okay, so it's not that. Okay, so we multiply through by 4, multiply each side by 4, 4's cancel. And then we subtract 7 from each side. We get 4x minus 7 equals y. Okay, so we want to make sure we know how to go through those steps.
Yeah, I forgot the sign and tried to divide it because it wasn't.
Sure. Those things happen. So we want to make sure we spend lots of time doing the homework problem, because the more homework problems we do, the more comfortable we'll be with going through these steps. And then the final step then is to substitute negative, not negative, but the inverse function of g for y. So the inverse function of g of x is 4x minus 7. Now, I want you to notice something kind of interesting here. You notice that the inverse function of g, 4x minus 7, equals f of x, 4x minus 7. And you'll notice that the inverse function of x, which is x plus 7 over 4, equals the function g of x, which is x plus 7 over 4. That's telling us that the inverse of g of x, shown here, looks like f of x, and the inverse of f of x looks like g of x, which says these functions are the inverse of each other. Okay, does that make sense to everybody? So now the next question might be, if I've got enough room here to do this, what if I take f of g of x? What does that look like? That can also be written f of g of x. Those are the same thing. And I'd say, well, the f function looks like 4, and then it has an x, but in place of x, I'm going to put g of x, which is this value here. This value here. So I'm going to put x plus 7 over 4. That's by substituting that for g of x. And then minus 7. And let's see what I get here. So can you resolve this for me then? Do the algebra So f of g of x equals this. So when I simplify, what do I get?
We get an X.
These cancel, those cancel, and we just get x. Okay, so if two functions are the inverse of each other, if I take f of g of x, I'll get x. So then the next question, of course, becomes what if I do g of f of x, which can be written g of f of x. So g looks like x. In place of x, I'll put f of x, which is 4x minus 7. And then plus 7 over 4. So that looks like g of f of x. So let's see here. I put in, did I do that right? That doesn't look like it's right. G of f. So g is this. So I'll put 4x minus 7 over 4. 4x minus, no, just 4x minus 7. So there's f of x. That's good. And then we'll do a plus 7 over 4. That looks like that's correct. Okay, and then we want to simplify again. What do we get when we simplify this?
X again.
X again, because we then this is an order of operations, isn't it? So we do 4x minus 7 plus 7 in the numerator. So in the numerator, those will cancel. And then we end up with 4x over 7. And the 4's cancel, we end up with just x. Okay, so we can tell then that these functions are the inverse of each other because we take f of g of x, we get x, and g of f of x, we get x. Okay. Questions on that at all?
So does that mean that if we take, for example, if g of x if is the inverse of f of x, so any g of x will, for example, sorry, if we have different equations for f and g of x,
Mm-hmm.
and then we do f of g of x and g of f of x, will they also equal x?
Only if they're inverses.
Okay.
That doesn't say that every f of x is an inverse of every g of x. This just says if they are inverses, then the inverse of f of x will equal g of x, and the inverse of g of x will equal f of x, if they are in fact inverses.
Okay.
Other questions?
And so
Wait,
like about, sorry, go ahead.
Okay, you can go first. Where is it that?
Okay, thank you. So basically what you're saying on the at the bottom part is when you I don't know how to, I'm just trying to get it in like word form, like what we're doing, if that makes sense. Like, so if the function of a function, the two functions are inverses of each other, it'll equal x.
Correct.
Thank you.
If the functions are inverses of each other and we take f of g of x or h of I of x or any two functions that are in fact inverse of each other, then g of f of x or f of g of x, and you can call these values anything you want. It doesn't have to be f and g. It's just the examples I'm using here. But if they're inverses, then we're always going to get x. That's correct. Other question? Okay. All right, let's see, which one did we do here? All right, let's try this one then. If I just say I'm going to give you a function y equals f of x, and I say 2x plus 7, and I say find the inverse of x. Are you able to do that? And if so, go ahead and do that. And then Open your mic and tell me what you get. And I guess anytime I'm asking for answers, I think I've explained that before, but I'm always asking for the process you use. I'm not looking for the inverse is the following equation. What I'm looking for is to find the inverse, I do the following steps.
I have a question.
Yes.
You listed 4 steps earlier.
Mhm.
For the first one, you said let y equal x. For the second, you said to swap or interchange the variables.
Mhm.
In the third, you said to solve the equation for y. What would the fourth step be? It would be just to simplify.
The fourth step is replace the inverse that we started with.
Okay.
Let's see, do I have that here somewhere? Let's see here. Maybe, yeah, over here.
Okay.
So 1, 2, 3, 4. So we placed F inverse with Y. And then when we got all the way down to the bottom, we had solved for Y. And then because we had been asked to find the inverse, we go back and say, well, we had solved for Y, so replace Y with the inverse that we were asked to find. Okay, so I guess if we had the same 4-step procedure here, step 1 through 4, can we use this same procedure then and find the inverse of the f of x, where f of x equals 2x plus 7?
Yeah, I used that for procedure. So first I replaced, first I wrote y equals 2x plus 7.
Equals 2x plus 7.
And then I swapped y and x. So I got x equals 2y plus 7.
Okay, so that's the swap.
And then for solving for y, I subtract 7 from both sides. So I get x minus 7 equals 2y. And then I divide both sides by 2.
Okay,
So I get y equals x minus 7 over 2. So I
mhm.
replace the y with f, f inverse of x.
Minus 7 over 2, right, Gopal?
Yeah.
Okay. Everybody agree?
Yes, x minus 7 over 2. Got the same.
Okay, so here's the inverse. Here's what we were given. And we went through our steps and we came up with the inverse. Okay, questions on what we did there? All right. What if I'm,
Professor, I have a
yeah, go
question.
right ahead.
I'm trying to understand what is the purpose of the inverse function.
I'll show you some graphs in a bit, but we might have a function that looks like this and the inverse looks like that. And the idea is we want to find out if we were to swap the variables, maybe the variables represent temperature and pressure, or just about any kind of variable you want, voltage and current. It allows you to interchange the variables and see what happens to the values of the equation and what happens to the shape of the curves if you were to interchange those values. You know, if in one location the values look like this and in some other location they look like that, we would be able to say, well, then given that case, we know what that curve or what those values are going to look like. Maybe we're at some other, if you go to the moon, maybe the functions are different because the weights are different, the gravity is different. And we say, well, if it were this much here, what would it be there?
Oh, okay. Thank you.
Other questions before we take another problem? Okay, let's say you're given f of x equals 4x cubed minus 1. So this is what you're given. And you're asked to find the inverse of x. Then we do step 1, step 2, step 3, step 4. So remember what the steps were then. First step was to, and let's get some new volunteers. We don't want the same people answering all the questions all the time. So let's let everybody have a chance. So for step 1, what did we do? We said, well, let y equal f of x. So we said, well, step 1, let y equals 4x cubed minus 1. That's what we did up here. And then for step 2, we did the swap. Remember? So if we swap this, what's that going to look like? X equals 4y cubed, right? Minus 1. If we swap those guys.
Yeah.
And then we want to solve. All right, let's go ahead and solve this. Solve that, and then when you've done it, go ahead and turn your mic on and step me through the process of solving x equals 4y cubed minus 1. We're going to solve for y. New volunteer.
I think the first thing you do is you add 1 on both sides,
X plus 1, okay.
and that equals 4y squared. Cubed.
Okay,
And wait, x plus 1 equals 4y cubed.
okay,
And then you divide by 4 on both sides. And
okay.
so, yeah, and then you also have to do the cubed root on both sides, and then
Cube root, okay, equals y. Okay, good. And then the last step was
the inverse of f of x equals the cubed root of 3 plus 1 over 4.
cube root of 3 plus 1.
X plus 1. Apologies.
Cube root of x plus 1 over 4. Okay,
I have different answer. No, different sign. It's x minus 1 instead of x plus 1.
all right. Now let's take it through step by step. Then did you agree with step 1?
Yes.
Okay. You agree with step 2?
X.
We
Yes.
swap the variables. Then you agree with step 3. We're going to solve for y. So we brought this x from the right of this negative 1 from the right hand side to the left hand side, and we got it to the left hand side by adding 1 to each side.
Oh, okay.
Make sense?
Yes.
So that's a plus 1 because we're adding it to get it to the other side.
Okay. Thank you.
Sure. So then we would say, looks like our answer looks something like that. Okay.
Yes.
All right. Let me see. That paper looks like that's been used up. Let's try another one here. Let's say I have 2 line segments. Line segment 1 goes from, let's say, -2, -2, and -1 and 0. So I might call that point 1 and that point 2. And as you know, I like to go left to right. So I put the leftmost point first. And if I were to plot that, I don't have to plot it, but let's say I plot it. And here's x, and here's y, and here's the origin. And I go -2, -1. So here's -2, 2, -2. So -2, -2, that's going to be down here, isn't it? And then -1 and 0, -1 and 0 looks like that's there. Okay. And then I have, let's say I have another line segment. So let's say there's a line segment goes like that. And then let's say I have another line segment that goes from -1, 0 to 1 and 2. So over 1 up 2. So maybe it goes to here. So that's 1 and 2. Okay, so I've got a line segment that goes from -2, -2, -1 and 0, over 1 and up 2. So it looks like this. Color that in so we can see that a little more. And then maybe we should highlight these a little bit so that we can see those a little better. Everybody see those okay? And if I were to ask you to say, if I said this blue line represents a function, say this is f of x equals this blue line. This is f of x. And I ask you to graph the inverse, plot and graph the inverse of x. You'd say, well, let's see, how am I gonna do that? I don't have an equation, but I have points on the graph. And the way we do that is to invert the points or reverse the points. So if point 1 is -2, -2, if I reverse those, I'm still ending up with -2, -2, aren't I, for point 1? So if this is point 1, now let's say point 2, if I swap these values, point 2 becomes 0 and -1, doesn't it? So point 2 becomes 0, -1. So I have a point here, 0, -1. And then up here at, if I call that point 3, which is at 1 and 2, and if I swap those values, maybe I'll call that the inverted point here. And let's say this is 1 and 2. If I swap those and I get 2 and 1. So I go over 1, 2 and up 1. I'm over here about here. So here is that 2 and 1. So now if I connect those points with a different color, there and there, and here's 2 and 1, and here's 0 and 1, and here was the original -2, -2, which didn't change. Then what I'm looking at here, the pink line is the inverse of the blue line. So if I had a f of x here and I said, what's the inverse? Then I would say, well, this thing is the inverse of x. This is f of x. Here's the inverse of f of x, okay? And we got that by simply swapping the values of the coordinate points. And when we swap this point, we get the same point, but here we got a different value. And here we got a different value. Okay, questions on that? Okay. Let's try. Let's see, what time do we have? We still got some time, so let's try another one. Let's say you're given y equals some function of x, and that's equal to, say, x squared plus 1. And let's say if x is greater than or equal to 0. And we want to find f inverse of x. So we swap y for f of x, and we say y equals x squared plus 1. Okay, and then what do we do in step 2?
X equal y squared plus 1.
So we swap the variables.
Yes.
X equal y squared +1. Okay, new volunteer. What do we do next?
You solve by first subtracting 1 on both sides,
X minus 1.
and then doing the square root. Yeah, that equal, and then that equals y. And then
Okay,
the last step would be saying that the inverse of f of x equals the square root of x minus 1.
okay. So here we have the inverse. Okay, everybody agree with what we're looking at here? So here is the inverse. Here is the original function. So now I'm going to ask you to graph. So let's say we have x and y. Here's our origin at 0, 0. And maybe we go out here. Let's see, 1, 2, 3, 4, 5. -5, 5, 5, -5, and here's a 0. And if I ask you to graph the inverse function, this function here, we could set up a table of values, couldn't we? We could set up x, and we could set up inverse of x. And we could say, well, let's see, what values can I plug in here? And I would look at this and I'd say, well, are there any restrictions on the value of x? Can you see any restrictions that we might have on the value of x?
X has to be greater than or equal to 0.
Gopal, have you answered questions before?
Yeah.
Can I have new volunteers so that everybody gets a chance?
Okay.
Ella, Ferris, Hudson.
So we're asking what the domain of x is, or sorry, I kind of missed the question.
Yeah, that's why we want multiple people involved. That's exactly what, who can explain the question? Alan, can you explain the question? Ferris, can you explain the question? Hudson? Jacob? Joseph?
So,
Go ahead.
so what? It can't be -1. It has to be more than. It has to be above 0 or positive.
So let's say it's 0.1.
Okay.
Does that work?
Yes.
Everybody agree that works? Everybody agree that works?
Yes.
Paul, you said you're the one that gave it to me. So I know you agree that it works. Is there anybody else that agrees that it works?
No.
I'm not sure.
All right. Who else can help me out here? What we've been given is let x equal 0.1. Well, can we put in values and plot at x equals 0.1 for this function? Now, this function happens to be the inverse, but we don't really care whether it's an inverse. It happens to be a function. We could call it y, or we could call it g, or we call it anything we want. But it's equal to the root of x minus 1. And I want to plot on a table of values, and I want to begin somewhere. And I think what I'm going to do then is move 0.01 over. 0.1 over. I'm going to start at 0. Can I plot at x equals 0?
No.
Yeah, I'd say no,
Why not?
because you can't take the square root of a negative number.
All right, we can, but it's not on the real number line, is it? It's an imaginary number.
Mhm.
So we're going to say that that is not available to us. How about 0.1? Is that available to us? New volunteer?
No, because 0.1 would also 0.1 would give us a negative number as well.
Still be negative. So what's the first value we can even plot?
It's 1 then? Positive 1?
It's going to be 1, isn't it?
Yeah.
Okay. Because that's the first time we can get something that isn't negative. So I can say, okay, if x is 1, what's f of x going to be, or the inverse of the inverse function? What's that going to be?
0.
0. Okay, because this is 1. 1 minus 1 is 0. Square root of 0 is 0. Okay, so I can say if x is 1, we're plotting 0, and we can't have anything less than that. All right. And I have 4 o'clock. Can we take how much break time do we need? Is 5 minutes enough?
Yep, 5 is good.
Yes, 5
All
is
right, we'll see you
fine.
guys in 5 minutes. Good work. Okay, any questions come up at the break? I guess we just keep plotting then. So let's see here. If X is what we want to take some value here. Taking the square root, and then we want the square root. Well, if X were 5, we'd have 5 minus 1, that's 4. And the root of 4 would be 2, wouldn't it? So we go out here 5 and up 2. So we're going to have a point here at 5 and 2. Point here at 0, no, at 1 and 0. And what if we go out one more value here just to see? If this were 17, 17 minus 1 is 16, root of 16 is 4. So 1, 2, 3, 4. And now here 5, 10, 15, 16 is quite a ways out, isn't it? So it looks like we're going to have a curve that sort of looks like that. If we were to plot more values in here. So we go from 1 and 0 to 5 and 2, and out here at 4 and 17, way out there. Okay, so we'll have something that sort of looks like this, and we said this is the inverse function, and we said that was f inverse of x. And then if we plot the f of x value, so let's go down here, f of x. If we have x at 0, f of x is going to be 1, right? So 0 we have up here at 1. And if we had x is 1, we would have 2, we'd have root of 2, so x is 1, root 2 is 1.4 roughly, so maybe here. And if x were, how far we want to go here? If x were 2, 4 would be root 5, so if x were 2, we'd be the root 5. Let's see, that would be approximately 2.3. So if out here up to, so maybe here. And if x were 3, it would be 3 squared 9, 10 be the root of 10. Roughly 3, 1, 6, 1, 2, 3. So it looks like it's sort of going up this direction, doesn't it? Sort of going up in the opposite direction. Okay. Now, if we, let's just call it some other color here. So now what we're showing then is that if we have some value or some function f of x and x greater than 0, so we're really not going to include this 0 point here. We're going to include something greater than 0, maybe 0.1 or something greater than 0 here. Then we'd have a line, a curve going up this way, and the other curve going that way. And so we plotted the table of values, and we plotted the two functions, the f of x function and the inverse of f function. Okay. Now, questions on anything we've done on that problem or anything we've done in this section on inverse functions? Because that's really all I need to cover on inverse functions.
Is it fine if you do it one more?
I'm not going to do one more. I can review this, but I want to make sure we've got time to do the next one. If we want to do, I would say this, take a look at you're going to do more of these in the homework problems, but as all we're doing is finding the inverse and plugging in values, just like we always do. We didn't do anything different. That you could call this Y, you could call this G, you could call it anything you want. But we just took the function that we created, which is the root of x minus 1, and simply put in the values. Right? So we did. We had x at 0, 0.1, 1, 157. We just plugged in some values and said, what happens at the f of x function and the inverse function, just like you have done many times when you're plotting a table of values. And then once you've got the table of values, you plot the points. And that's what we did. That's what we did here. Now, what I want to do in the next section is talk about distances and midpoint and circles. And we want to make sure we've got time to cover this section as well. So distance and midpoint formulas and circles, we have the following objectives. Which are, we want to find the distance between 2 points in the XY coordinate plane. Give you any 2 random points, and we want to find the distance between those points. We want to be able to find the midpoint of a line segment. We want to find, maybe we can even derive the formula of a circle. And we want to commit that to our brain so that we memorize what that is. Now we might want to have the equation of a circle at the origin. So if here's the origin, we have some circle centered at the origin, and we might have a circle that's not at the origin. We might have, here's the origin here, we might have some circle down here somewhere that's not at the origin. We want to be able to find out the equation of the formula for both of those. Okay, so those are the kinds of problems we want to go through in this section. So let's talk about distances first. And if I give you a couple of points, say I have a point here and I have a point here, and I say maybe this is x1, y1, and this is x2, y2, and I want to know this distance between those 2 points. And in general, what I want to do then is draw a horizontal line at this point and a vertical line through this point. And you'll notice that when I do that, I end up with a right triangle. So here's point 1, here's point 2. And if I could find point 3, whatever that is, then I'd have a right triangle here, wouldn't I? And if I have a right triangle, I can use Pythagorean theorem, a squared plus b squared equals c squared. So if I call this a and that b and that c, then I could say, well, this distance c is the square root of this distance and this distance squared. Remember that? Is that new, or you remember that? Okay.
Yeah, that's okay.
Okay. So given that we know the Pythagorean theorem, which looks like this, the main objective here then is to say, can we find the coordinates of point P3? And the coordinates of point P3, we'd say, well, we need an x coordinate. And it's not going to be this value, is it? It's not going to be x1 because that's here. Here's x1. We need something out here at x3. And it turns out that x3 and x2 are on the same line, aren't they? So that's the same as x2. And similarly, the y value here is going to be the same as y1. So I can say this is x2, y1, and that's that location. So now if I want to derive the distance, I could use the a squared plus b squared equals c squared. And then I have to come up with what a is. A equals, well, if I let a be this value here, that's the vertical distance. So that's going to be y2 minus what? y1, this value down here. Okay, and b is going to be equal to x2 minus x1, isn't it? Okay, so I've got a and b in terms of x and y, which is what I have in my xy coordinate plane here. So if I want to calculate the distance c, I could solve this equation, and I could say c equals, take the square root of each side, and I can say c equals the square root of a squared plus b squared. And then I just have to plug in the values for a and b into this equation. So the distance c, this hypotenuse, is the square root of a, and a is going to be y2 minus y1, and I'm going to square that, which it says here, plus b, which is x2 minus x1, and square that. So now I have the general form of an equation that gives me the distance between 2 points in the xy coordinate plane. Okay, I'm going to stop at that point and ask for any questions you might have on how we derive that equation. We're going to use this equation, but first we had to derive it. Okay, if everybody is okay with that, then let's just see if we can implement that equation. So let's say I give you a point at -1, -3, and another point going left to right of 2 and 3. And if I call this point 1 and this point 2, then I could call this x1 and this y1 and this x2 and
Sorry to
y2.
interrupt, but could you please move the paper down?
Yeah.
Thank you.
Let me move this up here a little bit so you can see better. There we go. Okay, can you everybody see this okay?
Yes, thank you.
Let me move this back here just a little bit more. Okay, so now we have the points. I could plot them or not plot them. And I won't take the time to plot them right now, but let's say we're looking for the distance between those 2 points, and we want to use the equation that we just got through developing, which was the distance between those 2 points. We said was, we could say x2 minus x1 quantity square plus y2 minus y1 quantity square. So the difference in the x values to get the horizontal distance, and the difference in the y values to get the vertical distance. And then we just have to substitute in here, don't we? So x2, well, we've labeled this as x2. So that's 2 minus what we've labeled x1. Here's x1, and that's -1. So minus -1, and we're going to square that, plus y2, here's the label for y2, and that's 3, minus the label for y1, and that's -3. Okay, so now we have the distance. We can get the distance between those 2 points by simply solving this equation. So distance equals the root of 2 minus is a plus, so 2 plus 1 is 3, and 3 squared is 9, plus 3 minus a minus 3 is a 3 plus 3, so that's 6 squared is 36, we have D, the distance is the square root of 9 plus 36. 36 and 9 is 45. It's a root of 45. And we can, get my other pen out here, we can simplify that, can't we? So that's going to be, if we factor this, we could say, well, 5 and 9, 3 and 15, those are factors. And this factor we can take the root of. So the root of 9 is 3, and the root of 5 is just the root of 5. So we can say, well, the length of that line between those 2 points is exactly 3 root 5. And that's the exact length. Now I could plot these if I wanted to. 1, 2, 3, 1, 2, 3. -1, -3, it looks like that's down here. And 2 and 3 looks like that's up here. So here's the line that I'm looking for here. And if I draw vertical through there and a horizontal through here, it looks like I have a right triangle. And then I've labeled this x1, y1, x2, y2. So I said x2, which is 2, minus x1, which was -1. So that gives me this distance, doesn't it? That gives me this distance here. And it turns out that's 2 and 1 is 3. And we could count over. You're not always going to be able to count over, but we're -1. So there's 1, 2, 3. We can see that that works. And similarly, in the vertical direction, we're down 1, 2, 3, and we're up 1, 2, 3. So that's going to be 3 and 3 is 6. And we know that this distance is the square root of this distance plus this distance. And in exact form, it's 3 root 5. And one of the reasons I point out its exact form, because you always want to read the question and make sure you're answering the question that's asked. If the question said, what's the distance, what's the exact distance between these 2 points, which are these points listed here, then you'd say, well, here's the exact distance. It's 3 root 5. If the question were different and said, give me the distance in decimal form to 2 places, then what would the answer be? How about a new volunteer on that one?
You said the
We use
decimal.
calculator.
Okay, yes, you use your calculator, 3 root 5, and the calculator looks like it says 6708. So 6.7082. And if I ask for it to 2 places, then I would say 608, round that up. So it's going to be 6.71, isn't it? And whatever the units are. If you're not given units, you don't have to supply units. If you are given units of inches or feet or centimeters or yards or whatever the units were, then you would want to put those units in here in your answer. But if no units are given, then 6.71 is a fine answer. Okay, questions at that point? Anything we did there? Okay. Let's take a look at another problem here. Let me get some paper out here. If I give you 2 points, let's say 1 and 2, that's point 1, and point 2 is at 7 and -3. And I ask you for the midpoint. Let's say I ask you for the midpoint of those 2. Where is the midpoint? And you might say, well, let's see here. If I were to graph this x, y, 1, 2, 3, 4, 5, 6, 7, 1, 2, 3, 1, 2. So I over 1 and up 2. So I have a point here at 1 and 2. And I have a second point at 7 and -3. So it's going to be roughly down in here somewhere. 7, -3. And here's 1 and 2. And I have a line that sort of looks like that. And I want the midpoint of that line from here to here. And on good graph paper, you might, if it falls on an actual intersection of two lines, a horizontal and vertical line, you might be able to tell where the midpoint is. But for the most part, you're probably not going to be able to do it that way. So I don't recommend you solve any of these problems graphically. I recommend that you solve them algebraically. And so the midpoint, if I call this point 1, if I call this x1, y1, like we've done before, and this x2, y2, then the midpoint in the x direction is going to be 1, x1, well, maybe I should just say that, x1 plus x2. So I add these together and then divide by 2. We have 2 points. So that kind of gives me the average, doesn't it, of the x, 7 plus 1. And then the other and the y direction, so I could say y1 plus y2 over 2. So in general, that's going to be what the midpoint, where it would be located. And so now if I substitute in actual values, x1 is 1 plus x2 is 7, divide that by 2, and then y1 is 2 plus y2 is -3, and that's over 2. So it looks like my point is going to be at 7 plus 1 is 8 over 2. That's going to be 4, isn't it? And the y value, so that's going to be the x midpoint. And the y is going to be 2 minus 3. That's going to be -1 over 2. So that's -1/2. So we'd say, well, it's 4, 1, 2, 3, 4, and down 1/2. So it's going to be approximately here somewhere. And I'll say 4 and -1/2. So I know exactly where it is. It's at 4, -1/2. And then depending on how good my graph paper is, I could say, well, it's about here. So the midpoint then for these 2 points using the algebraic method for solving, x1 plus x2 over 2 and y1 plus y2 over 2, we get these two coordinate points, 4 and -1/2. And if we were asked to plot it, then we could do that and say, well, it's approximately here. 1, 2, 3, 4, 5, 6, 7, 1, 2, and so forth. Okay. Questions on that at all?
Wait, so to find the midpoint, you just divide the points by 2? Is that how you did it?
You add them together and then divide by 2. See what we did here?
Oh, yeah.
x1 plus x2 over 2. y1 plus y2 over 2.
Oh, okay. Got it. Thank you.
Any other questions on what we did there? Okay. Let's say we're asked, and this is kind of an interesting and fun one, if we were asked to come up with the equation of a circle at the origin. Find equation of circle at the origin. So here's x and y, and maybe we go out to, let's just take an example, and maybe we connect these points. We say we have points here and here and here and here. And maybe we do, or maybe we don't know where they are, but we know we're at the origin here. And we know we have a radius here. That's the radius of the circle. And we have a point anywhere on the circle, and that point is X and Y, isn't it? It's over X and up Y. So wherever it happens to be, it's any X, Y on the circle. We'll just pick a point here. So if I drop a perpendicular line from this any X, Y point down to my X axis and make that perpendicular, that is to say, comes into the X axis at right angles, then I have a right triangle, don't I? And I know about right triangles on the Pythagorean theorem, that this side squared plus this side squared equals this side squared. So if this is in fact any point X, Y, then the distance along the horizontal here is going to be X, and the distance along the vertical here is going to be Y. So I have a right triangle, and by the Pythagorean theorem, I say X squared plus Y squared equals R squared. Okay. So I look at that and I say, well, gee, that's true for any point on this line, this circle. I could pick any point on that circle, and it's going to be X squared plus Y squared equals R squared. And we say, well, that's interesting. Then it looks like to me that that's the equation of a circle at the origin. There it is. Find the equation of a circle at the origin. We just did it. Now, if I gave you a couple of points, or if I gave you a radius, if I said, find the equation of a circle at the origin with a radius of 9, R equals 9, then what's the equation of that circle? Maybe this point is at 0 and 9. Now what's the equation of that circle become? X squared plus Y squared equals radius squared, that's 9 squared, that's 81. So X squared plus 9 squared equals 81. If I gave you the equation, X squared plus Y squared equals 81, and ask you for the radius, you'd say, well, it's the square root of 81. That's what the radius is. It's the square root of this, which is 9. Okay, which is this. Making sense to everybody here? Questions at all? Thought I heard a question, but maybe not. Okay. Well, what if the circle is not at the origin? Maybe we have a circle. Maybe here's X and Y, and here's the origin. And maybe we have a circle that begins down here at, I don't know, -6. So we have a point here at 0, -6. And I give you, let's say, radius of 10. So if R equals 10, and the center of the circle is located at 0 and -6, and I ask you to plot points on that circle and give me the equation of that circle. Let's see, you'd say, well, the center's here. I can draw a line through there, and I already have a line through there. My radius is 10, so I'm 6 to here, and I'm 4 more to this point here. So what is the value of that point? Well, it's 0 and then 6 and 4, so that's going to be 0 and 4, isn't it? And then if I'm looking for a point out here, well, if the radius is 10, if I go out here to 10, and the location of that is going to be -6 and 10, isn't it? So there's the point there at well, that's not right, is it? That's going to be over 10 and down 6. So we go over 10 to here. X value comes first, and then down to that value. How about over this direction? So here we're negative 10 and negative 6, aren't we? Here's positive 10 to the right. Here's negative 10 to the left. So we have a point here at negative 10 and 6. And then if we come down here 10 more from negative 6, and we go down 10 more, we're going to be at what? Negative 16. And we're on the X or the Y axis. So our points would be, a center would be here at 0, negative 6. And we have a point over here at over 10 because that's the radius, and negative 6. And here we're left 10, and here we're down 10 from negative 6. So it looks like if we drew a circle around here, it would sort of look like that. And here's our radius here. And then if we're asked to calculate the equation of that, and we say, well, the general form is x squared plus y squared equals the radius square, and the radius is given as 10, so that's going to be 10 squared or 100. And then we want to move the center. It's not at the origin, which is 0, 0. It's still on the y-axis. So how much is that shift? Do we shift in the x direction, positive or negative direction? I don't shift at all, do I? Because I'm right on the y-axis. So the equation is going to be x squared plus, now the y value, I'm shifting, and I'm shifting it by 6. And so when I set up my equation, I say, well, that's y plus 6 quantity squared. So if I have a negative value here, it would shift it up. A positive value shifts it down. So my equation then becomes x squared plus the quantity y squared plus 6 equals 100.
So I have a question here.
Yeah.
So we shifted y down. So why did we do plus 6?
Well, if we're shifting, if you're doing a shifting for an equation, we have, let's say by convention, we call H a horizontal shift and K a vertical shift. So in general, the equation of a circle not at the origin would be shifted H and K. So we would say X minus H quantity square plus Y minus K quantity square equals the radius square. Now remember, when you're doing equations and you say Y equals X squared minus H, do you remember which direction this H shifts the value?
Yeah, like
This
plus-
shifts it to the right, doesn't it?
Yeah.
Okay, so here, this would, a negative value would shift it up. Okay, so what we're saying here then, we have a minus, or a plus value. So in this case, K equals negative 6, well, I guess it's 6 because we're setting down here. Okay, so we're looking at the value here. We're looking at this point here. So if we call this a positive value, we'd shift it up. Negative value shifts it down. Positive value shifts it left. Negative value shifts it right. I think we've gone through that in some of the other equations that we've looked at when we're talking about shifting. If we talk about shifting a curve, which way it gets shifted.
Yeah, but the equations we were shifting when we were shifting in the
Mhm.
like y direction, like if If it was a plus, then it
Well,
would bring it up.
that's where we had y equals, let's say, mx minus h plus k. That's this value here. That's the k value that would shift it up. If it's minus, it would shift the curve down. But that's not what we're doing here. Here, the k value is part of the equation. And so if we have a negative value here, it shifts it in a positive direction, and a positive, it's just like we have for x, only it applies to y.
Okay.
It's the same logic. It's not this k. It's y minus k. And if we're talking about squaring this, x squared plus y squared. And to prove that to yourself, you could stick that in your graphing calculator and see which way, if you take a positive or negative on the x and a positive negative on the y, and you could move your equations around. You can see how those get shifted. But it ends up being the opposite the way you would think. And the way I think about it is, if I say, well, if I take this x minus h and set it equal to 0, then x equals a positive h, y minus k equal to 0, y equals a positive k. So this would shift it in the positive k direction, or y minus k, and an x minus h would shift it in the positive h direction. If you want to think of it that way, either way would work for you.
Okay, thank you.
Sure. Let's see, here we go. Okay, so let's say you're given the following. I would like you to come up with the equation and plot. So find equation and plot points for a circle if h equals equation h equals -3, k equals 1, and r equals 2. Okay. So go ahead and work on that for a minute or two, and we'll see if we can work out what the answer would be.
Do you mind reminding whether h goes with x or y?
This goes with x, k goes with y.
Okay, thank you.
Sure. So the general form, I'll rewrite the general form here. X minus h quantity square plus y minus k quantity square equals r square. That's the general form of the equation. And so we just have to substitute those values in. Okay, everybody get that? So here we get x minus a minus, so that's going to be x plus 3 quantity squared plus y minus 1 quantity square equals 4. So that's the equation that we're going to be using. And now we want to see if we can plot that. So H and K are the center of the circle. So we're going to go -3, 1, 2, 3, and +1. So I'm going to have the center of the circle here. And then I'm going to have a radius of 2, 1, 2. So I'm going to go over to here and back to here. And I'm going to go up 2. It's going to put me here. And down 2, which will put me here. So now if I'm looking at connecting those points and telling you what those points are, well, let's see. This is -3 and 1. That's that point. So if we go over to here, we're not at -3 anymore. We've added 2 to it. So now we're at -1, and we're at the same y value. So that'd be 1. Over here, we were at -3, and we subtracted 2 because the radius is 2. So now we're at -5, and we're still at +1. We go up 2. We were at -3. These are both going to be on the -3, aren't they? They're both at -3. They're on this line right here. So then we are, here we're up 1, but we have a radius of 2. So we're up 2 more. So that's at 3. And down here, we're at 1, and we have a radius of 2. So we subtract 2 from that, and we're at -1, aren't we? So if we label these points at -1, 1 here, -3, 3 here, -5 and 1 here, -3 and 1 here, and -1 and -3, +1 here. Okay, and our circle is going to be along this line here. Okay. So again, find equation and plot the points given H, K, and the radius. So general equation is shown here, x minus h quantity square plus y minus k quantity square equals r. Now, if we were at the origin, h and k would be 0. We're not at the origin. So we go left 3, which is the h value, and up 1, which is the k value, to give us the center of the circle. And then we can develop the equation. X minus h is x plus 3. Y minus 1. Now you notice y minus 1 here, and we're going upwards. We shifted up. Here we shifted left. Here we shifted up. So if you said x equals -3, y equals +1, you're going to get the h and k values as shown above here. So I think we've done everything we needed to do then. We came up with the equation, and we plotted the points, and we plotted 4 points on the circle on the x and y axis for the circle. Yeah, go right ahead. Yeah.
What is the radius on the circle?
The radius was 2.
Why do we use it to draw the circle?
The 2 is the radius. So if I were to say, here's some point at the origin, draw me a circle with radius 2, then you would say, well, here's my radius of 2, and I want to always be 2 from the origin. So I would draw a circle like this, and anywhere on this line here, I'm a distance 2 from the origin. So here's 0, 0, and any point out here has a length of the radius of 2, of a value of 2. If you were to, let me see if I've got a compass here that would work. Do I have a compass around here somewhere? I used to. I don't know if I still do or not. Well, yes, I can use this one. here's a compass. And if I say this value, this distance is 2, then I can scribe a circle around here that looks like that, which is a better circle than what I did when I drew it. So this compass then will draw a circle of any radius I want, where I'm defining the radius to be the length between this point and my lead point out here. Okay, here's my compass. Okay, I'm guessing you've all used a compass. Maybe you haven't, I don't know. But a compass has a point here and a lead point here that allows me to draw with it. I can pick any point out here and draw a circle.
Okay, thank you.
Sure. Let me put the equipment away here. All right, let's see. Do I have another problem for you? That was really all I need to cover on distances, midpoints, and circles. I can stop at this point. It's all I need to cover on that section. Are there any questions that you guys have on calculating distances or midpoints or circles before I go into the next section?
Wait, so like when graphing the circle, so H and K, is that stuff as like X and Y? Is that how you found the circle?
H and K are the displacement in the horizontal and vertical direction of the center of the circle.
Okay.
They tell you where the center of the circle is. So here's a circle not at the origin.
Mhm.
Well, where is it located? It's located at H, which is -3 in the X direction, and K, which is +1 in the Y direction.
So from there, how do you know like how I guess large you want the circle to be? How would you know?
The radius.
Oh, it's too my fault. It's all coming together. My bad.
No problem.
Thank you.
So this tells you where the center is. This tells you how large the circle is.
Got it. Thank you.
Yeah. Other questions before we go on to the next topic of inverse functions?
Just a quick question. So
Yeah.
we did not cover horizontal line tests, correct? On 1.8.
On 1.8 we're talking about inverse functions, right?
Yeah, because the objectives you wrote horizontal test, line test.
Yes. All right. If I have a function, let me see if I've got, do I have an example of that? If I have, remember we had this and that, and we had one was the inverse function, which looked like this. And then we had the regular function, which looked like that. And if let me see, where do I have that? Do you have that here somewhere? Let me see here, find the. Okay. And maybe I should just write it out. A function, and I'll just use f of n function. A function f has an inverse that is a function f inverse if, and this is the key point, if there is no horizontal line that intersects the graph of the function f at more than one, I'll spell it out, point. So function f has an inverse if there is no horizontal line that intersects the function at more than one point. So if I have a function that looks like this, and I use my horizontal line test, well, it intersects the function at more than one point, doesn't it? So that says a function that looks like this does not have an inverse. Okay. I could say it has an inverse. If I were to take just that part of it, I could say there's an inverse. Or if I could say just take that part or that part, anywhere where I don't have a line that intersects the function at more than one location, then it has an inverse. That's the horizontal line test.
But if you look at the graph above, it seems as if the two, as if we draw a horizontal line, the horizontal line will, but like if we draw.
Here's the function. Does this horizontal line cross the function at more than one spot?
Not there, but if we draw it maybe a little to the downside. I think
Here?
it will. It's, yeah.
It crosses this line at more than one spot?
But if we extend the line, won't it?
This is a different function. These are two different functions.
Oh, okay. I see.
Here's the function. Here's the inverse function. These are two different functions. So
Oh,
this f of x looks just like the blue line. And that blue line extends up that way and it stops here. And the horizontal lines test says I put a horizontal line on that function. Does it cross it more than once? And the answer is no. Therefore, we have an inverse function, which looks like this. If I had a function that looked like this, and I tried my horizontal line test, I'd say, well, yeah, that horizontal line crosses that function in more than one spot. Therefore, a function that looks like this does not have an inverse.
okay. Thank you.
Okay, yeah. Other questions? Any other questions? All right, let's see here. What other do we need to talk about here? Yes, let's try this one. If I give you, get a fresh piece of paper here. If I give you a function f that looks like the following. Let's say it goes from -3, -2, -3, let's say it goes from here. Here's -3, here's -2, here's 2, 4, 2, 3. And it goes to say -2, +2. Let's say it goes to here. So it goes to -2 and 2, from -3, -2, and then it goes over to, let's say, over 4 and 1. So I have some function that does this. Goes to there and then goes to there. And I'm going to say that's y equals f of x, like that. And then I ask you to draw or sketch or graph or however you want to call it, the inverse. So here's the function. And I ask you to draw the inverse. And I have the function that goes here to here to here. And now I say, draw the inverse. Do we have enough information to draw the inverse? And if so, what would we do to draw the inverse of that function? Well, we're going to want to swap points. So if this is x1, y1, and this is x2, y2, and this is x3, y3, then we're gonna swap these points. So we're going to say -2, -3. So -2, 1, 2, -3. So we have a point here, -2, -3. There's that point. And I take this point up here at 2 and 2, and I swap those and I get 2, -2. 1, 2, -2. So I get something over here, 2, -2. And I'll highlight these so that you can see them better. And then I have a point out here at 4 and 1, and I swap those points and I go 1 and 4. So I'm up here at 1 and 4. And now let's say I connect that second set of points here and here. So the blue line is f of x. The pink line is f inverse of x. So here's f of x here, blue line. Yeah, the inverse of x is this pink line here. And we got that by simply swapping the coordinate points on the y equals f of x line. We're given 3 points. We swapped the values and plotted, and we got f inverse. If I want, I could create a table of values, x, and I could say f of x, and I could say f inverse of x, just like we have done before. And if I say, okay, if I'm out here at -3, f of x at -2, at -2, I was at 2, and at 4, I'm at 1. And here's my f of x values, which I'll just put in the same color here. So -2, 2, and 1, -2, 2, and 1. So f of x at -3, I was at -2. At -2, I was at +2 for my f of x value. And at 4, I was at +1, which is this value out here. And then my inverse values, well, what did I do? I said, well, if I swap these values, then the inverse is going to be at -2 and -3. I've simply swapped these. Here I'm at 2, -3, which is over here. And over here I'm at 1 and 4. Over 1 and up 4. So I could say, I could plot these values, but what I'm plotting is what I've got in the pink line here. Okay, so if x is, when x is -2, this is -3. When x is 2, so if I come out here to 2, we're at -2. And if I'm up here at 1, if I say 1, then I'm down, I'm up at 4. So if I want to create a table of values, I could do that. And I could put them in order if I wanted to, -3, -2, -1, 0, 1, 2, 3, 4, and so forth, and plot different points. But what I've done here is plotted the points that I've shown in my graph above. And so when you're talking inverses, you can either, if you're given an equation, you can solve that equation by doing the 4 steps we talked about, substituting y equals, and then swapping the x and y values, and then solve for y, and then substitute f inverse for y. That's, remember the 4 steps we talked about earlier. And if you've got an equation, you can find the equation of the inverse. If you've got points, you can find the points on the inverse by simply swapping the x and y coordinates, as we've done here. Questions on that at all, what we've done there? Okay, now that's all I have for today, but I will stay after for any questions that you might have. And let's see, tomorrow we're going to cover, what did we say we're going to cover? 1.10. Do I have that here somewhere? Tomorrow, yeah, 110. So tomorrow we'll cover 110, and then I will take any questions that you might have on the first, on anything in chapter 10. I don't have anything formally prepared. It's just your best preparation for the test is simply to review your homework problems, review the lecture notes that you have from what we've covered, and to review the example problems in each section that we've covered. That's your best review. And I'll just answer whatever questions you might have tomorrow, if you have any. Other questions?
Sorry, maybe I wasn't clear, but so today we did 1.8, 1.9, and 1.10.
No, we didn't do 10 today yet.
Okay.
We'll do 10 tomorrow.
Okay, thank you.
Yeah. Well, I guess I shouldn't say tomorrow. I guess I should say Wednesday, the
Yeah,
27th.
Wednesday, you were freaking me out.
Yeah, the 27th. I have one class that meets daily and one class that meets Monday, Wednesday. So yeah, we always just follow this schedule. The next class is whenever it says in the schedule, in this case, the 27th, which happens to be a Wednesday. And then we'll have a test on the 15th, excuse me, the 1st, November 1st, and so forth. Well, it's just, we're just following this schedule. Other questions? All right, that's all I have. We'll plan on seeing you then on Wednesday. We'll cover section 110. We'll cover any questions you have on problems from 1.8, 1.9, and we'll take any questions you have over anything on the first 10 sections of chapter 1. Okay.